Hello everyone, myself Dr. Ranjith Kumar Gatla, working as an Associate Professor in the Department of Electrical and Electronics Engineering. So in today's class, we are continuing our discussion on numerical problems on ABCD parameters. So in the previous classes, we have already discussed some numerical problems on Z parameters, Y parameters and H parameters. So now in today's class, we are going to discuss some numerical problems on the ABCD parameters. So these ABCD parameters is also called as a transmission parameters. So we have already discussed this topic, like how to find the ABCD parameters, okay, or what are the applications of the ABCD parameters, and what is the need of finding the ABCD parameters for a given electrical circuit. These things we have already covered in our previous classes. So in the theoretical conceptual classes. So in today's class, we are exclusively discussing the numerical problems based on the numerical problems, okay, to find ABCD parameters. So first let us start with the first problem. So determine the transmission parameters. So sometimes, as I mentioned, okay, sometimes they ask you like determine the ABCD parameters or the transmission parameters, because the ABCD parameters are also called as the transmission parameters. So determine the transmission parameters in the S domain for the network shown in the below figure. So here of course here also for just simple understanding, I have considered a simple T network. So later on we will consider some little more complicated networks to solve or to find these transmission parameters. So here first of all, we should know, okay, what are those 4 transmission parameters. So the 4 transmission parameters here are the A, B, C and D, right? So these are the 4 transmission parameters, right? So first, the same way we will find A and C, then after we will find B and D. Then how to find A and B? Sorry, A and C. So to find A and C, what we will do, to find A and C, so what we will do is, we are making the output terminal as a open circuit. The output terminal as the open circuit, right? So by making the output terminal as a open circuit is nothing but we are making I2 is equal to 0. Then the second case here, the B and D. So these transmission parameters we can find. Of course, this is also referred to the secondary side, because unlike in the previous cases like Z parameters, Y parameters and hybrid parameters. So there what we used to do is, so in the first case we usually making either the output terminal as a open circuit or the short circuit, and the second case we will do for the input side. But in this case, in the transmission line parameters, so both we will do at the output side only. So in the second case, we will make the output terminal as a short circuit. So which means here we are making V2 is equal to 0. Right? So first, then how to find and what is A, what is B, what is C, what is D, we will see now. Okay. So first to find this one, okay, so we just converting this, because here 1F, this is capacitor is there. So for our simple understanding, here already they defined here the parameters are in the S domain. So that's why we are converting all other parameters into the S domain. Of course, here in S domain, what is that, the resistors are same as usually, but here the capacitance, okay, the 1 farad we can convert it into as a 1 by S ohms in the S domain, right? So for that again, here first what we need to do, first as I mentioned, first we are going to find A and C parameters. So to find A and C parameters, okay, as I mentioned, here first what we are going to do is, we are making the secondary terminals as a open circuit and we are connecting one voltage source V1 to the primary side, right? So that this circuit will become like this, right? So here we are making the open circuit at the output terminals and we are connecting the voltage source V1 to the input terminals. Now, by using this circuit, now we are going to find A and C parameters, okay, of the transmission parameters. Then, what is A and what is C, right? So here A is equal to V1 by V2. Here, let me write here. A is equal to V1 by V2 at output terminal is open, so I2 is equal to 0. Similarly, C is equal to I1 by V2. I1 by V2 by making again I2 is equal to 0, right? So now we need to find A and C, right? So further, we are going to use this circuit. Okay, this circuit is of course just we are making the output terminal as a open and the input side we are connecting the voltage source V1, right? So to find this one, first let me find the total current for this particular circuit because actually I am trying to make it V1 by V2 circuit, V1 by V2 equation. So for that here, I am just finding the total current I1. Okay, so I1 which is equal to V1 by R, right, or V1 by the total resistance of the circuit. Anyway, here this 1 ohm is connected to the open circuit, so we will neglect that one. So we are having only 1 and 1 by S. So here 1 and 1 by S are in series. Then I is equal to here the total voltage here it is V1 by 1 plus 1 by S, right? So if you simplify this, then you will get here S into V1 by 1 plus S. This is I1, right? So but of course here I1 and V1, this equation is in terms of I1 and V1, but here we don't have any I1 and V1 terms. So that's why what we can do is next let us find V2, right? So V2 is, what is V2 here? Okay, the current flowing, because the V2 is nothing but the voltage across is 1 by S. Okay, the voltage across 1 by S. What is the current flowing through this 1 by S? Here I1. Of course I1 and I2 will go, but will flow, but I2 anyway it is 0 because of the open circuit. So only the current I1 will flow. So here V2 is equal to 1 by S into I1. Right. So to find V1 by V2 here, as you know, V2 is equal to 1 by S into I1. So from this I1 is equal to S into V2. Then substitute these I1 value here. Okay. Then this will become S into V2 which is equal to S into V1 by 1 plus S. Right. So here S gets cancelled. So actually V1 by V2. So here V2 you can send this side and V1 you send this side. This 1 by S. Then here V1 by V2 which is equal to 1 plus S. So which is nothing but here it is A. The transmission parameter A. This is how we can find the transmitter parameter A. So here also the procedure is same like in the previous cases. Okay, the only thing here, okay, whatever the network reduction technique that you can apply, okay, but finally what you have to do is by using those equations we have to find the V1 by V2 value. Similarly, I1 by V2 value, right? So how we can find I1 by V2? See from this equation, right? You just send V2 this side, okay. Then here I1 by V2 which is equal to S, okay. So which is nothing but here it is C, okay. Then here A is equal to which is V1 by V2 which is equal to 1 plus S, okay, at I2 is equal to 0. Then similarly here C is equal to I1 by V2, okay, so which is equal to S at I2 is equal to 0. So now we have calculated A and C by using this particular circuit. So this circuit is, the condition for this circuit is, so we have applied the open circuit at the output terminals and we are connecting the voltage source V1 at the, the input side. Then next we are going to find B and D. So how to find the B and D? Then of course again we are taking the secondary terminals. So in this case now we are applying the short circuit across the secondary terminals, which means we are making the output voltage equal to 0 by short circuiting the output terminals, right? So by using this circuit, now we are going to find the B and D parameters, which are the transmission parameters. Then first of all, we should know what is B and what is D. Okay, so here B is equal to minus V1 by I2. Of course, anyway, at V2 is equal to 0. Then here D is equal to here minus I1 by I2 at V2 is equal to 0. Right. So if you see here V1 I1, okay, in the numerator V1 I1, right? So here also in the numerator V1 and I1, right? In the denominator here V2 and I2, because we are making I2 equal to 0. So here in the denominator, here in the both the cases you are getting I2 because we are making V2 is equal to 0. So this is also a very easiest way to remember the equations. Okay, to remember the equations for the ABCD parameters, right? So now this is the circuit, right? So in this circuit, so then how to find this one, right? So here again, let me find the total voltage, because here we have to make the relation between V1 and I2, right? So V1 and I2 are I1 and I2. So further here, what I'm going to do here is, let me find the total voltage V1, right? So the total voltage V1 or the what is that, the total current I1, that also we can find, right? So for that, let me find first, the total current I1, let me find. So I1 is equal to V by Z, okay, because the total impedance. So first let me find Z. So here Z is equal to, here the 1 and 1 plus S both are in parallel, okay, and that combination is in series with the 1 ohm resistor. So that's why here this will become 1 plus, okay, so 1 by S into 1 by S plus 1. If you simplify this, then 1 plus, okay, so here 1 plus S by S, sorry, this is 1 by S only because into, so 1 by S by here 1 plus S by S, so S gets cancelled, then here it will become 1 plus 1 by 1 plus S, 1 by 1 plus S, or in another words here it is S plus 1 plus 1 2, so S plus 2 by S plus 1, which is equal to Z, right? So then here we know I is equal, or I1, the first the current I1, which is equal to the total voltage is V1 by Z, right? So which is nothing but here V1 into by Z, Z is S plus 2 by S plus 1, so that it will be, make it as S plus 1 by S plus 2, right? So this is V1, right? So any V1 and I2, but we don't know this is V1 and I1, okay. So let me go with the other equation. So here let me write this one. I1 is equal to here V1 into S plus 1 by S plus 2. Right. Then now we know the total current I1. So now by using the current division rule, we can find the current I2. Right. So here the current I2, which means I2, the current I2, of course, anyway here it is minus I2 because it is in the opposite direction that we are considering. So the current I2, which is equal to the total current, here it is I1 into, okay, so the opposite resistor here it is 1 by S by 1 plus 1 by S, right? So if you simplify this, then here, of course, anyway, so because what you have to find here, V1 by I2, okay, so here we can find I1 from this, okay, so in the place of what is that I1, you can substitute this one so that you can eliminate what is that, the I1, so that we can find either V1 by I2 or I1 by I2, right? Then for that here, yes, I1 into 1 by S by 1 plus 1 by S, so here it will become I1 by S plus 1. This is minus I2 is equal to, right? So then here, as we know, I1, I2, here both are there. So because here I1 by I2 is there. So then this you just send to this side and this you can send to this side, right? Then here, of course, anyway minus is there. So minus I1 by I2, which is equal to S plus 1. So which is nothing but here it is D. Here it is D, right? So now V1 by I2. So here now you know the I1 value. I1 is equal to what is that? Minus I2 into S plus 1. If you substitute here, okay. So which means here I1 is nothing but minus I2 into S plus 1, which is equal V1 into S plus 1 by S plus 2, right? So V1 by I2. So just send I2 this side, okay, and this what is that? This one is this side, so that you will get here V minus V1 by I2, which is equal to S plus 1, okay. So into S plus 2 by S plus 1, right? So this S plus 1 gets cancelled. Then here finally what you will get, what is that? Yeah, minus V1 by I2, which is equal to S plus 2, which is equal to, what is that here? B. Yeah. So this is how we can find the ABCD parameter. So from the previous case, we have calculated this is A and this is C, okay. And from the second case, now we have calculated this is D and this is B. So this is how we can find the ABCD parameters or the transmission parameters for any given circuit, right? Then let us go with another problem. So here, it is the other way to find the ABCD or the transmission parameters. So which means here, of course, with respect to the two conditions, they have given the values of some parameters. So first one is when the port 1 is open and when the port 1 is short circuited, right? So the port 1 is nothing but the output side. Okay, let us consider. So which means while making the output side as an open circuit, what are the two parameters that we can find? Okay, in the previous case that we have seen. Okay, so which are A and C, and by making the output terminal as a short circuit, which means by making V2 is equal to 0, what are the other two parameters that we can find? Those are B and D. The same way here also we will do, right? So already we know the ABCD parameters equations, which means from the parameters. So how we can write the what is that the equations? Okay, actually these ABCD parameters we got it from those equations only. So let me write those equations here, because the V1 and I1 equation that we will get. So here first let me write here V1, which is equal to A into V2 minus B into I2, right? And then when you will get here the V1, because A and B, of course, let me write later. Then I1 is equal to here C into V2 minus D into I2, right? So first, because when port 1 is open, okay, so here of course in a reverse way that they have taken, so which means input side that they have given. So port 1 is open is nothing but here the I1 equal to 0. Okay, I1 equal to 0 and substitute all other values. When port 1 equal to 0, I1 is equal to 0, what are the values that they have given? V1, V2 and I2, right? So V1, V2 and I2. So when port 1 is equal to 0 here, right? So V1, okay, so which means here, let me write here. So when port 1 is equal to 0, V1, yeah, this is 1 millivolt. So which means here 1 into 10 to the power of minus 3, which is equal to A into V2. So A into here V2 is 10 minus B into here I2 is 200 into 10 to the power of minus 6. Right? Then similarly, when the port 1 is short circuited, so which means when the port 1 is short circuited is nothing but V1 is equal to 0. So when V1 is equal to 0, okay, so then what is that V1 is equal to 0? So I1, then we will get the second equation. So I1 is minus 0.5 into 10 to the power of minus 6, which is equal to, so here C into what is the V2 value? 5 and minus D into what is the I2 value? 80 into 10 to the power of minus 6. Okay. So by solving these two equations, right? So from I1 equal to 0 and from V1 is equal to 0. By solving these two equations, then you will get the values of A, B, C and D. Right? A, B, C and D values that you will get. Okay. So then how to get these A, B, C, D values from this equation, right? So then finally you will get the values of A, B, C, D is here. So let me write here. A is equal to, I have already calculated. So for time being, I'm not doing the calculations here. Okay. So I'm already having the answers. So the answers I'm writing here. So here A is equal to minus 4 into 10 to the power of minus 4. And here B is equal to minus 25 ohms. And C is equal to here minus 5 into 10 to the power of minus 7. And D is equal to here minus 0.025. So these are the values ABC. So which means here they have given the two conditions. Okay. So by using these two conditions, we can develop the equations, right? So by solving those equations, we can find the ABCD values, right? So this is the other way to find the transmission line parameters, right? Not from the circuit, just from the given values and conditions. Also, we can find the transmission parameters. Now we are going to solve the third problem. Right. So here, of course, this circuit is little complex, not more complex. Okay, a little complex compared to the previous circuit that we have discussed. Right. So then, for this particular circuit, again, we need to find the transmission line parameters. Of course, for any circuit, the conditions are same. Right. So the condition will not change based on the circuit. So for any circuit, the conditions are same. But sometimes you may need to convert. Sometimes you may need to convert the given circuit into the standard form. Okay. So either in the T network form or in the pi network form, right? So that it will be easy to find these ABCD parameters. So for that here, of course, the same way. So first here, by making here I2 equal to 0, which means by applying the open circuit at the secondary terminals, so that we can find the parameters A and C. So then here, by applying the open circuit at the output terminals and just by including the voltage source V1 at the input terminals, then the circuit will become like this. So for this particular circuit, or by using this circuit, we can find A and C. So already we know what is A and what is C. So then here, how to find then these A and C transmission parameters. So the same way, first let me write, because here the two loops that you are having. So this one left side one loop and the right side another loop. So first let us apply the KVL to the first loop, right? So KVL to the first loop. So if you apply the KVL to the first loop, so here V1 is equal to 1.5 kilo ohms into I1. So 1.5 into 10 to the power of 3 into I1 plus, so 10 to the power of minus 3 into V2. So let us consider this is equation number 1, right? Then with respect to the second loop, okay, so I am just applying KCL at A, at node A. This is the node A, at node A. So if you apply the KCL at node A, so you can see what are the currents entering and what are the currents leaving, that you can see, right? So if you apply here, this 40 into I1 is leaving, and again the current flowing through the 40 kilo ohms is also leaving. But anyway, here I2 is entering, but I2 is equal to 0, so we no need to take that particular value. So that's why then here 40 into I1 plus, so here what is the voltage here? Here it is the voltage is V2, right? So the I is equal to V by R. So here the voltage is V2 by what is the value here? It is 40. So 40 into 10 to the power of 10 to the power of 3, because it is kilowatts. So which is equal to 0, right? So then here from this we can find the I1 value. So here I1 is equal to So if you simplify this, so minus 6.25 into 10 to the power of minus 6 into V2, right? Then now substitute the value of I1, in equation number 1. Substitute I1 in equation number 1. So that here this equation will become V1 is equal to 1.5 into 10 to the power of minus 3 into, so here I1 is minus 6.25 into 10 to the power of minus 6 into V2 plus 10 to the power of minus 3 into V2, which is yes, because why we are substituting, because here we have to make it V1 by V2 so that we can find A1. So then take V2 as a common and send the V2 to the left hand side. So then finally here V1 by V2, okay, so which is nothing but here it is A. So at where I2 is equal to 0, okay, then the value here it is minus 8.375 into 10 to the power of minus 3. So this is how we can find the value of the transmission parameter A. Right. So now we need to find the transmission parameter C. So what is the transmission parameter C? Here we know already C is equal to the same, here it is I1 by V2. C is equal to, let me write here, C is equal to I1 by V2. So from this equation, as you can see, right, so I1 by V2, which is equal to C, which is equal minus 6.25 into 10 to the power of minus 6. This is the value of the C parameter, right? So here it is very simple. What we have done, just we applied the basic the network reduction techniques like the KCL and KVL. So by applying this KCL and KVL, we are getting equations. Okay. So by using those equations, we can find the various parameters of the network, or the transmission parameters of the network, right? Then in the second case, what are the other two parameters that we need to find? B and D. So to find the other two parameters B and D, what we have to do? So we have to apply the short circuit at the secondary terminals, right? So short circuit means, why we are making the short circuit? Okay, we should make the voltage, output voltage, equal to 0. So for that reason, we are applying the short circuit across the output terminals. Then in that case, the circuit will become like this, right? So just we have applied the short circuit at the output terminals to make V2 is equal to 0. Then by using this circuit, we can find the other two parameters B and D, right? So now how to find the B and D? Here also the same way, either you can apply the KCL or KVL, whatever the way that you can find, it is up to you. Okay, there is no particular way that you should follow this particular method, something like that. Okay, so finally what we have to do, because as we know here D is equal to minus I1 by I2. Okay, and again, what is other parameters here? B is equal to V1 by I2, of course, minus V1 by I2. So then just we need to get the equations like I1 by I2 or V1 by I2. So by using either you may apply the KCL or you may apply the KVL, right? So further, let me apply the KCL at B. Here again, let us consider in this case the node is B, right? So in this case, of course, now you will be having the I2 also, because before it was I2 is equal to 0. Okay, but here the I2 is not equal to 0, only V2 is equal to 0, right? So that's why here what you will get, the 40 into I1 plus, actually before what we have done, because here V2 by 40 into K, because now this 40K is in parallel with the V2. So here V2 is equal to 0. So something by 0 is equal to 0. So that's why here it is 0. 0 is equal to I2. Right? Then here D is equal to, or finally this will become 40 I1 is equal to I2. Right? So what is I1 by I2? So you just send this one. So I1 by I2, which is equal to 40. but as we know, which is nothing but D, so minus 40. Okay, so I1 by I2, which is equal to, yeah, oh no, not 40 here, it is 1 by 40. It is minus 1 by 40. So this is D. Then how to find V1 by I2? So V1 by I2, of course, anyway here V2, yeah. Then we can apply the KVL to the loop 1. So by applying the KVL to the loop 1 here, V1, which is equal to 1.5 into, what is that, 10 to the power of 3 into, okay, 3 into I1. Okay, so here applying the KVL to the input side, so V1 is equal to 1.5 into 10 to the power of 3 into I1. Okay, so here, because of course here, what is that, plus 10 to the power of minus 3 into V2 is there, but anyway here V2 is equal to 0. So that's why we no need to consider this one. So that's why I'm just neglecting this one. But we know here from I1 is equal to, what is I1 is equal to I2 by 40. So substitute here. So V1 into 1.5 into 10 to the power of 3 into, here in the place of I1, we can write it as a I2 by 40. Right. So then what is this here? V1 by I2. So just to send this I2 this side. So here V1 by I2, if you simplify this, so anyway, what is V1 by I2? Here it is V is equal to minus V1 by I2, which is equal to minus 37.5 ohms. So this is V. See, the circuit is looking like little bit complex because of the because of the dependent voltage and current sources, but the solution is very easy. Fine. So this is how we can find the ABCD parameters. Then let me take one more example. Okay. So here, suppose if you get the circuit like this, if you want to do as it is for the circuit, the ABCD parameters, it is a little bit difficult. Okay. So for that here, what we are going to do is, so first let me reduce this circuit into the standard form of what is that, the pi RT network. So for that here, what we are going to do here it is, so just convert this delta network into the star. So like this, star, right? So then of course, because here all the resistors in the delta network having the same value, so that's why when you are going to convert the delta into the star, if all the resistor values of the delta are same, then we can make it as a R is equal to, here it is 1 by 3. Sorry, not 1 by 3. R is equal to, here this is R by 3. R star equal to R delta by 3. So which means here it is 3 by 3, which is equal to 1. So that's why here for all the what is the resistors in the star network having the same value, that is 1 ohm resistor. So that's why here this network is converted into this way. Then again after this, the same as usual, because this problem of this network is similar like the first problem that we are discussed in this today's class, right? So then of course same way. So you just what is that, apply the open circuit at output terminals. So which means by making I2 equal to 0, we can find A and D parameters, right? And again here by making the output terminal as a short circuit, which means the output voltage equal to 0, right? So that we can find the B and D parameters, right? So this is just for your exercise purpose, so you can do by yourself, because I already explained the procedure, right? So this is the way to find the transmission line parameters or ABCD parameters, right? So in the next class we will discuss the other, of course there is a interrelation between these parameters is also there. So which means suppose if they give the ABCD parameters, so from that we can find the other parameters also. So how to find these the interconnection between the these the parameters or ABCD or H parameters, that we will discuss in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.